Welcome to Synthesizing Your Personal Biological Blueprint. We will explore how to use AI-driven precision nutrition, advanced training, and continuous biomarker feedback to engineer your optimal human operating system, starting from the cellular level. This program is brought to you by the Series of Thoughts team. Today, we will cover a framework for practitioners and biohackers looking beyond generic protocols. This complete system ranges from raw biomarker data to a self-correcting AI feedback loop that evolves with your unique biology. Chapter 1 focuses on synthesizing your personal biological blueprint. Your body generates countless signals daily. The challenge is not data collection, but contextualization. We'll show you how to feed the right biomarker inputs into an AI model for truly personalized interventions. We start with epigenetic clock data, such as Horvath's, Grimmage, or Dunedin pace, which measure biological aging by analyzing DNA methylation patterns. To leverage this with AI, export methylation reports, include delta scores, and timestamp every upload for tracking longitudinal changes. Continuous glucose monitors, or CGMs, provide rich time series data on how your body responds to food, sleep, and stress. Combine this with epigenetic data for powerful AI-driven decisions. Export 14-day averages, tag contextual events, and feed the data in a structured time series format. Context is essential. Raw numbers are meaningless without environmental metadata like sleep scores, heart rate variability, and prior meals. The AI needs this information to generate interventions that reflect your actual physiological state, not just a snapshot. The quality of your AI output is proportional to your prompt engineering precision. A master prompt must force the model to weigh nutrient density against specific inflammatory markers. Define your biomarker hierarchy, establish nutrient density rules, and embed constraint logic. The master prompt architecture includes an identity block to set the AI's role, a biomarker input section for your latest data, constraint rules for boundaries, and a defined output format. This layered approach ensures personalized recommendations based on your unique filter. Your baseline plan should prioritize mitochondrial health, as fat loss without mitochondrial support accelerates biological aging. Focus on biogenesis, membrane integrity, and ATP efficiency. Key priorities include CoQ10, PQQ, NAD plus precursors like NMN/NR, OMEGA3-DHA, and creatine monohydrate. Prioritize lean muscle preservation over simple weight loss. Muscle is your greatest metabolic asset. Your baseline plan should protect lean tissue by setting a protein floor of 1.6 to 2.2 grams per kilogram of lean body mass. Never exceed a 20% caloric deficit to prevent muscle catabolism. Building your biological blueprint involves a complete data pipeline. It starts with collecting biomarkers, structuring prompts, AI processing, and generating personalized protocols. This process adds context, preventing the AI from defaulting to population-level averages. Chapter 2 focuses on recursive feedback loops for muscle architecture. Training without real-time feedback is training blind. We'll introduce a system where an AI coach continuously adapts your resistance protocols based on recovery, heart rate variability, and biomechanical signals. AI-designed resistance training protocols move beyond rigid periodization. Intensity is HRV-gated, reducing volume when heart rate variability drops. Recovery scores from sleep and fatigue are integrated daily, and volume is auto-regulated based on RPE-based ranges and cumulative fatigue. The AI acts as a biomechanics coach to protect aging joints. By feeding it joint angle data, load distribution, and pain reports, the model can identify compensatory patterns, suggest exercise substitutions, and prescribe corrective mobility work. Implement a weekly recursive check-in protocol. On Monday, dump your data, HRV, training logs, and recovery ratings. Tuesday is the AI audit, generating a revised protocol. Wednesday is execution, and Sunday is reflection, feeding forward into the next Monday's dump. The goal is to increase intensity without metabolic burnout. The AI tracks a burnout risk index. It detects sympathetic dominance and triggers a deload protocol automatically. Progression is gated by recovery milestones, and metabolic flexibility is checked using RER and CGM data. The recursive feedback loop is a 5-phase cycle. Collect biomarker data, analyze recovery signals, adjust the protocol, execute the updated session, and audit outcomes weekly. This refines the model's understanding of your unique adaptation profile. Chapter 3 focuses on precision nutrition through hyper-personalization. Generic advice is obsolete. Your genome, microbiome, and daily stress create a unique nutritional fingerprint. Learn how to instruct AI to build a customized supplement and macronutrient stack. Genetic predispositions drive supplement selection. Upload SNP reports to the AI. For example, MTHFR variants impact folate recommendations. APOE status modifies fat intake. VDR polymorphisms affect vitamin D dosing, and CYP genes influence stimulant timing. Static meal plans fail because needs shift daily based on stress. The AI generates dynamic meal plans by analyzing training load, sleep architecture, HRV/cortisol proxies, and CGM response. This ensures your nutrition responds to yesterday's physiological demands. A 24-hour response cycle to elevated stress demonstrates dynamic adjustment. If low HRV and poor sleep are detected, the AI recalibrates macros, reduces the glycemic index ceiling, and adds calming supplements like magnesium glycinate and ashwagandha to the next day's plan. Automating grocery lists is the bridge to real-world execution. Instruct the AI to prioritize ORAC-scored foods, making every shopping trip a targeted antioxidant intervention. The AI removes the cognitive load by cross-referencing your plan with local availability. The AI prioritizes antioxidants in tiers. Tier 1 includes polyphenol powerhouses like wild blueberries. Tier 2 focuses on sulforaphane sources. Tier 3 includes astaxanthin and omega-3s. Tiers 4 and 5 integrate inflammation modulators and adaptogenic fungi. Precision nutrition delivers measurable results. Achievable benchmarks within 90 days include a 34% average reduction in HSCRP, a 22% drop in glucose variability, and an 87% protocol adherence rate due to automated meal prep and reduced decision fatigue. This hub model shows the AI nutrition engine pulling from 6 distinct input streams to generate biologically precise and practically executable outputs, bridging machine intelligence with meal preparation. Chapter 4 focuses on calibrating your long-term cognitive and physical peak. Optimization is an infinite game, requiring a permanent human-AI partnership that tracks cognitive decline, projects longevity, and pivots strategies as your biology evolves across decades. Structured daily journaling is biomarker data. The AI can parse qualitative entries for cognitive trends, analyzing vocabulary diversity, emotional valence, and coherence. This provides proxy measures for executive function and mental clarity invisible to wearables alone. Sleep architecture is cognitive infrastructure. The AI integrates sleep staging data to understand its impact on mental performance. It detects deep sleep deficits and recommends interventions. It tracks REM creativity correlations and aligns supplement timing with your circadian rhythm. Longevity trajectory modeling is a powerful application. By feeding the AI longitudinal biomarkers like epigenetic age and inflammatory markers, it projects your biological aging curve. The model identifies where strategic, timely interventions yield the greatest health span returns. Your AI system must evolve with your biology. It detects phase transitions and automatically adjusts protocols. Key pivot points include hormonal shifts, metabolic transitions like changes in insulin sensitivity, cognitive benchmarks, and musculoskeletal changes indicated by DEXA scans. Sustained vitality emerges from a permanent, self-correcting feedback loop. Establish non-negotiable daily data inputs. Schedule quarterly deep reviews with fresh blood work and scans for a, quote, firmware update. Finally, build in versioning to track the evolution of your protocols. Your Vitality dashboard tracks key longitudinal metrics over years. An 18-month trajectory, as shown, demonstrates the potential. A narrowing biological age delta, improved heart rate variability, and optimized average glucose, all driven by the human AI system. This complete system architecture ensures synchronization. Data collection, AI processing, and human execution operate across daily micro-adjustments and annual strategic pivots. Quarterly checkpoints are critical for aligning all 3 lanes of action. Key takeaways. Structured data is the foundation. Prompt engineering is a clinical skill. Recursive loops beat static plans, preventing burnout and preserving muscle. Finally, think in decades but act daily, using quarterly recalibrations to align your strategy. You now have the complete framework for your personal biological operating system. The difference between optimization and stagnation is implementation. Start with one data stream, write your first master prompt, and run your first weekly audit. Your health span will compound from there.